Hello, ladies and gentlemen. We have been talking about the different types of bonding. So far, we have talked about covalent bonding, where they share electrons, and we have talked about ionic bonding, where electrons transfer from one atom to the other. Today, we are specifically going to talk about the characteristics of covalent and ionic substances, so that you can tell some of the things about these substances, whether they're even sometimes if they're ionic or covalent, just by the different types of properties that they have. And we are going to start with covalent properties. Okay, first off, there is relatively weak attraction between atoms. That is why they are able to come apart so easily. Such things as going from water to steam. Okay, in case you haven't figured it out, water is covalent. There is a relatively low melting point. If you think about it, ice, water, melts relatively cold. I mean, 32 degrees Fahrenheit is quite cold to have a melting point. Okay, next. Nearly all gases and liquids at room temperature are covalent. So that should tell you a lot about the things surrounding you. Not all of them, but most of the liquids and gases. Things like the air that you breathe, for example, water, the things that you drink. Okay. Many of the solids, however, are also covalent. That makes it kind of tricky sometimes to tell if they are covalent or ionic just based on their properties, or their phases, if they're solid, liquid, or gas. One of the things that's very important to tell about covalent things is that they are good insulators. If you think about most of the things that are insulated, whether you think about insulation in your roof, which is made out of glass, whether you think about the insulation around wires, that's plastic, for shoes, that's rubber. There are a lot of different types of things, and in reality, for most of the space vehicles, they have ceramic tiles as insulators against the heat from the sun and from the fuel itself. So they make very good insulators. Some of their other properties they don't all have, but it gives you some ideas about some other things too. For example, covalent things can be stretchy, and they can go back to their original shape. That's what it means to be elastic. So when we talk about a rubber band, we're talking about a covalent structure. It has the ability to stretch and to bounce back. Now, one thing you may not have realized is covalent compounds also can store energy. Whether you're talking about your food, which by the way for the most part is covalent, or whether you're talking about plastic explosives, when the bonds between them are broken, energy is released. So whether you're talking about getting calories out of your food or talking about the fireball of an explosion, that is the energy stored in these covalent bonds that gets released when the molecules get broken apart. Okay, there are other properties as well, but they are fewer different substances. But these are some of the overall ones. Okay, for ionic compounds, they have a very strong attraction between their atoms. For example, ionic substances have no smell. They literally hold together so tightly that there is no smell to them. If you try to smell an ionic substance, you'll smell the container, but you won't smell the substance itself, because there are no atoms floating up into your nose for you to be able to smell them. And that's what smelling is when the molecules go up into your nose and you can detect them. Ionic substances also have a very high melting point. This clip of a video is going to show an ionic substance, and it has the ability to melt lead once it is melted. So they're putting it in and they're starting to melt the ionic compound. You can see it's a mostly clear liquid now. And they're going to put it on the lead, which is metal. Adding some more lead so you can see it on top. Okay, and you can see that the lead is actually melted. And even though the ionic compound is already cooled, the metal is melted. Okay, other properties. At room temperature, all ionic compounds are solids. And lastly, all ionic compounds will dissolve in water. That is because water has a charge to it, so that the ionic compounds get pulled apart. Next, ionic compounds are good conductors when they're dissolved. That's why salt water is not the place to be when a lightning storm happens. And lastly, ionic compounds form crystals and are hard and brittle, so if they are hit, unlike covalent compounds, which are stretchy and elastic, they will